Let's start the practice problems with number 3. Well, numbers 3, 4, and 5, because they're matching. So first we'll do the work and we'll see which of the pictures this looks like. Right. We want to match this to a picture that they give to us, A, B, or C. So first of all, it's negative, so we know we're going to start measuring in this direction. That's the negative direction. And thinking about it in the positive direction might be helpful. You know, we know that this is 180. We know that this would be negative 180. Okay, so that's negative 180, which is not enough to get to 240. If we kept going to this one, that'd be negative 270, so that'd be too far. But 240, negative 240 would be 30 degrees away. So it'd be something like that. We go negative 180 and just a little bit more, another 60 degrees is negative 240. So we take a look, and that looks like letter B. So that moves us on to number 4, 600 degrees. So we know that it's in the positive direction. It's 600 degrees. We know we could just go right around one time, 360 degrees. 600 is close to twice as much, but it's not all the way. So let's just keep going in like maybe 90 degree increments. So we go from 360 to another 90. That would be 450. And then another 90 would be 540. And another 90 would be 600 and, let's see, 540, 630. So we've gone too far. We need to backtrack a little bit. So we're at 540 and we want to go to 600. That's another 60 degrees. That puts us right about there and not that much. So we go around one full revolution, another 180, and just a little bit more, and that looks like letter C. And number 6, 3, 4, 6. Yes, that's right. No, 3, 4, 5. Negative 9 pi over 4. Okay, so I know this is your first look at radians. And you could be done by process of elimination. It is letter A, but let's use our brains a bit more than that. So you could take a look at the picture that we drew earlier. This one here. This one shows that this is pi, this is half of pi, so it's pi over 2. This is a quarter of pi, so it's pi over 4, and so on. That's how we labeled all those. So pi over 4, right? This is over 4. This isn't 1 pi over 4. This is 9 of those. And it's in the negative direction. So if this is pi over 4, remember, it'll help you to think. Pi over 4 is the same as 45 degrees, halfway to 90. So here's negative 45, or negative pi over 4. Start to make that transition into radians. Here's negative pi over 4. This would be negative pi over 2. Or negative 2 pi over 4. You can just count by pi over 4s. So here's a pi over 4, and here's 2 of them, 3 of them, 4, 5, 6, 7, 8, and 9. Right, so we would go around in the negative direction, pi over 4, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all the way around. And then pi over 4 more than that, or 45 degrees more than that. That's what we're looking at, and indeed that's what A looks like. Alright, so that helps us hopefully get a grasp on positive direction, negative direction, the fact that we always start measuring on the positive x-axis, that standard position. So, brings all those things home. Alright, now we're going to do kind of what we just did. Let's try number 8. 8 wants us to draw, like we just did, 450 degrees. 450, it's in the positive direction. I'm going to start moving this direction. It's more than 360, so I might as well just go ahead and take care of that. Go around once. And let's see, if I go another 90 from 360, add 90 to 360, and that's 450. All the way around and 90 degrees more, that's 450. Okay, that's the spiral shape is how we kind of tell someone in another country that I've gone around 450 degrees. I've gone around a full revolution and a little bit more. Let's try number 12. Right, getting into the radians here. Negative 5 pi over 3. Remember that pi over 3, a single pi over 3, not 5 of them like this is, but just one of them. One of them is the same as 60 degrees. It helps to go back to what we know. It's the same as 60 degrees. And it's in, we're going in the negative direction. So here would be right here, 30 degrees away from 90, 60 degrees from the horizontal. That would be pi over 3, or 60 degrees. Pi over 3 radians, 60 degrees. Okay. So we could count by pi over 3s. Here's one of them. 2 of them would be the same as 120 degrees. 3 of them would be the same as 180 degrees. Pi radians. Halfway around the circle is pi radians. Okay. But that's 3 pi over 3, 4 pi over 3, 5 pi over 3. Learn how to count by pi over 3s and pi over 4s and so on. So this comes in the negative direction all the way around. There's negative 5 pi over 3. And number 13. 26 pi over 9. Okay, I don't know about you, but I do not want to count out 26 of these ninths of a pi. Okay, so hopefully what we, through grasping, most importantly for understanding, we realize, right, this from here all the way to this half, to halfway around the circle. That's pi, okay? And we're counting by ninths, pi over 9, ninths of pi. So to get from here all the way over to there by ninths, that would be 9 of those, right? That would be 9 pi over 9 would be the same as pi, okay? So how many of those could we make, in 26? Well, this much would be 9 of those. This much would be 18 of those. If I went another... Well, let's just draw that because that's not. We have made that much of an angle. To go all the way around, that'd be 9 of them, 18 of them. We haven't gone far enough. We need to go to 26. If we go all the way around here again, then we'll be at 27. Right? This would be 9 and 18, and then 27 would be 3 of those half circles. That's a little too far, and these pictures don't have to be exact, so it's almost there. It's just 1/9 away. So there. That's a good sketch of 26 pi over 9. All right. Now, all right. So here is where we'll introduce a term, and it's pretty straightforward. It's called coterminal. Coterminal means means with, or the same, and terminal refers to the terminal side of the angle, the place where we stop measuring the angle. So if two angles are coterminal and they're in standard position, that means that they start in the same place. Well, that means that they end at the same place. So here, I'll give you a quick sketch of an example. Here is an angle from here to there. Okay. Now all other angles we're agreeing to start measuring from the same place. So say I measured an angle going the other direction, coming all the way around like this, and I stopped measuring there. I stopped measuring at the same place as I measured this other angle right here. So they are coterminal. They have the same terminal side, the same ending. Let's say we measure another angle. This one goes all the way around and just a little bit further and ends at the same place. Now it went 360 degrees and just a little bit more, but it stopped at the same place. It has the same terminal side, so it's coterminal. All right, let's draw another picture, take another look at that. Here's another angle. Now, we've established what it means to be coterminal. So let's say, how would I find an angle that's coterminal with this angle, given that this is the angle that where I am? So any other angle that ends in the same place is going to be coterminal with this angle. So how do I get from here to another angle that also ends in the same place? Well, can I come from here and go over to there? Would that be coterminal? No, it would not. This is not the same ending place as this. If I were to start here and start to go around, I couldn't stop until I came all the way back around. Right? So whatever angle I want to find, I need to leave from here, go all the way around, completely around, 360 degrees. Then I will have found another angle that's coterminal. Let's say that, let's say this was 60 degrees. So this was 60. I started at 60 and then I went all the way around and stopped at the same place. If I go all the way around, that's a full circle, that's 360 degrees. So take 60 degrees, go another 360 degrees, and you have a coterminal angle. That's 420 degrees. Right? Yeah. So then 420 degrees is coterminal with 60 degrees because they end in the same place. All right? Well, what about radians? Let's look at a small picture of radians. Say this is pi over 4. Okay, pi over 4. There's from there to there is pi over 4. Let's say I wanted to go from pi over 4 all the way around. Well, then I will have found a coterminal angle in radians. But I can't take pi over 4 and add 360 degrees because they're not the same thing. For pi over 4, you can't add 360 degrees. It's like adding 4 inches to 3 feet. You got to have the same thing. So what in radians, how far would that be? Well, remember that halfway around is pi. So another halfway around is another pi. How many pi is that? 2 of them. Add 2 pi. Okay. So we're going to add 2 pi to pi over 4. Of course, we need a common denominator, so this would be 8 pi over 4. So altogether, that's 9 pi over 4. All right. I could do the same exact thing just in the other direction. I could subtract 360. I could go the other direction. Right? Take off this little bit that 60 degrees was and go from here all the way around, and that would be a negative angle because I've gone past all the positiveness it had, and now I've gone the negative direction. Okay, so you could have a negative angle that's coterminal. All right. So let's take a look at some actual, from the homework problems. 15 gives us 70 degrees. Okay, think about just a quick picture of 70 degrees. It's somewhere right here. If I wanted to leave 70 degrees and find another angle that's coterminal, I'd have to go all the way around. I could go all the way around again and again. I could go in another direction, but every time I go and leave 70 degrees, I need to come all the way around the circle before I find an angle that's coterminal. Okay, so that would mean that I need to go from 70 degrees and add 360 degrees. That would be 430 degrees. 430 degrees, since it's 360 degrees around from 70 degrees, and that puts us right back where we started. Well, it's coterminal then. 430 is coterminal with 70. Another part of this question is they want us to find a negative angle. So then I must want to go, not in the positive, keep going positive, but come back negative, so that I'll have a negative angle. So subtract 360 from 70. And that's a negative 90 degrees. No, that can't be right. Negative 290 degrees. So negative 290 is coterminal with positive 70 degrees. Got just another minute, so we'll try another problem here. 17. Negative 125 degrees. Again, they want to find a positive and a negative angle that are coterminal with negative 125. Well, since negative 125 is already negative, let's take negative 125 and we'll subtract 360. It's going to be a 5, 8, and a 4, 485, negative 485 degrees. Now let's take negative 125. We want to go in the positive direction, so let's add 360. Okay, so let's see, that would be 3, 5, and 1. 135 degrees. No, that doesn't seem right. No, 235 degrees. Okay, so positive 235 degrees, that is coterminal with negative 125, and negative 485 is coterminal with negative 125. I'll see you in the next video.